when we talk about reactions of the aldehydes themselves, basically, we're going to have 2 reductions, okay? And then 1 oxidation. Then we have a test. So basically, look at what happens. The reductions, we know them, okay? First, we say reduction with NaBH4. We already know about this guy. We know we got to put him in ethanol and put a little bit of acid. We know about him. And we know that the double bond O becomes an OH. Bang! So we can do a reduction with NaBH4. We know about him. So do we have to put him? No. Okay, I'll just put him. Here is what he had. Double bond O. And then we put an H if it's an aldehyde to show that the last thing, this is the last carbon, okay? You must show that this is the last carbon. So you put it bonded to the H. Now, that is the aldehyde. So here we have some aldehyde here. What happens if I take him through NaBH4 in ethanol? Okay, a little bit acidic, H3O plus. What happens? What am I doing to him? I'm reducing him. So what does he become? An alcohol, basically. Ding, ding, ding. This becomes an OH. We know that there's now another H here, but we don't show it. Okay, it's an invisible thing. We're done. That's all you got to do, right? What about when you want to do for the aldehyde? Let's do for the aldehyde. What aldehyde are we going to have? The same thing that we did last time. W double bond O, and we take him through. So remember, if you want to name this 1, 2, 3, 4 carbons, so it's going to be butanol. And since it's on the first position from the left, we call it 1-butanol. Here, what is it going to form? Butanol instead of butanol, and it's 1-butanol. Here, what do we have? Double bond O here. What do we have? It's 1, 2, 3, 4, 5 carbons, so it's pentanon because it's a ketone. And what position is the double bond? Oh, it's by position C, so it's 3-pentanol. Then what are we going to make? 1, 2, 3, the W. We make it a single bond. We make it an OH. And what is it going to become? Pentanol. And it's on position 3, so it'll be 3-pentanol. You are done, okay? That is if you put NaBH4 in ethanol, remember with ethanol, and then you're going to put a little bit of acid dissolved in water. So that's it. That is what you have, okay? That's the first one, to reduce. Now the second one, another reduction, okay? Number 2, okay? Reduction using hydrogen, okay? Here we are just using hydrogen itself, hydrogen gas, okay? But we need a PT catalyst, a platinum. Every time we use hydrogen to reduce, we always need a platinum catalyst. So whatever reaction it is. So here, what are we going to have? Let's have our aldehyde, whatever it is, double bond O bonded to an R. We know that that's our aldehyde, and we show the H. What happens? It's going to meet hydrogen. Okay. What do we need? We need a platinum catalyst, and he is going to be reduced again to an alcohol. Again, same thing. So this becomes a single bond OH. Okay. And we know that there was an H. We have another H appearing, and is bonded to the R. That's what happens. Okay. We get a primary alcohol. Okay. Because this is a primary alcohol, because if you see this carbon where the OH is bonded is only bonded to one other carbon. That's what happens when we come from an aldehyde. Let's see, reduction of a ketone, same thing. So reduction of a ketone, we have our carbon, can put our double bond O here and our R prime, and we add hydrogen, but remember we need a platinum catalyst. What are we going to get in this case? Reduction, again, reduction to an alcohol. The double bond O becomes a single bond and OH. So R, C, R prime, this becomes single bond OH, and then we add an H somewhere else. So because it's not bond line, it's displayed, we can put our H like this, and we are done. This is going to be a secondary alcohol. Whatever you're going to get, okay? Whatever alcohol you get, change the double bond, make it a single bond, and OH, then put another H somewhere. Right? And you're done. That's the second. Now the last one is going to be oxidation. Right? So we only have 3. Yes. Only 3. Yes. So what is the oxidation? What am I going to use in my oxidation? This is now, listen. There we were preparing, making the ketone by oxidizing an alcohol, making the aldehyde by SWAN and PCC. Now we want to oxidize to another thing, to come from aldehyde or ketone and oxidize it to another thing. Now my question is, can you oxidize a ketone? No! You can only oxidize a secondary alcohol to a ketone and it stops there. But if we are not using SWEN or PCC, we can actually oxidize an aldehyde. So for oxidation, it is only the aldehydes that are oxidized, only the aldehydes. And we are oxidizing them now using the big guys, K2, Cr2, O7, or KMnO4, or Na2, Cr2, O7, the big guys. These are the ones that can oxidize an aldehyde to a carboxylic acid. So let's have it. Aldehyde, yes. R bonded to C, double bond O, then some H. Basically, that's what we have. So let's put the R going down like this to show that it's a trigonal plane. This guy is going to be oxidized. We can put whatever we want. KMnO4. Then what is he going to form? Oh, carboxylic acid. Basically, this H becomes an OH. So it's going to be R, same thing, bonded to C, double bond O, and then here it becomes an OH. Wow, yes! So it came from an aldehyde, okay, and it became a carboxylic acid. That's what happens here, okay? That's what you got to do. Whatever you get, if it's an aldehyde, it's going to go to a carboxylic acid as long as it is an aldehyde, not a ketone. There, let's have one. H, double bond O. That's an aldehyde. The moment I see an H in the last step, double bond O like this, I know it's an aldehyde. And how many carbons does it have? Here, 1, 2, 3. 3. So it's propanal, okay? That's what we have here. Propanal. And what am I going to do? Oxidize it, please. KMnO4. What am I going to get? 1, 2, 3. Same thing, but this now is an OH, double bond O. Basically, that's the end. And what does this become? Propanoic acid. You are done. That's your propanoic acid because it has 1, 2, 3 carbons and it's an acid. And that's the end of it. That's the end of it. Now, the last thing which I'm going to show you is now the tests, okay? Tests for aldehydes. That's the last thing I'm going to show you. The tests. The test for aldehydes, okay? The test. There are two of them. One, we call it Tollens test or Tollens reagent, okay? We make what we call Tollens reagent and we do what we call Tollens test. Let me show you what happens. All right, so here is the Tollens test. Look at it, the positive test for an aldehyde. If you put silver plus ions, okay? Silver plus. My gosh, what is going on? If you put this, excuse me, let me stop this. If you put silver, Ag plus ions, then you are going to get, when they find an aldehyde, they will be reduced to silver solid. Okay? And that is what you see. This mirror-ish, we say silver mirror. That's what we say. Silver mirror color. Okay? Because what happens is silver goes to the walls of your test tube inside and it's pastes there. And it's a solid. And that's why you see it like a mirror here. Okay? That's the same thing you're seeing here. Look at the bottom. You can't see on the other side of this test tube. It's like a mirror. Okay? That's what we have. That is for tollen. So, I don't know how you're going to remember that tollen is silver. Tollens test. Okay, these two tests we are doing are only for aldehydes. For aldehydes. So, what they do is they oxidize the aldehyde to be a carboxylic acid, and then the guys get reduced. So we have our aldehyde, okay, which is whatever the aldehyde. We don't care about what it is. Really, we don't. But then we'll only show this guy, this silver plus, because he is the one that is part of the reaction. The other guys are catalysts, okay? They are there in the solution, but let's say, could we call them spectator? So we have ammonia in water, which in actual fact, it is like this, NH4OH, okay? Ammonium hydroxide. But anyway, we have this, and this silver was in silver nitrate, okay? But anyway, we leave it. We just put it as the silver. We're showing that he is the one that is going to be reduced to silver solid. Okay? And what happens to the aldehyde? It becomes a carboxylic acid. So you have it like C double bond O. Instead of an H, you have an OH. Basically, that's what changes. I know you won't forget this. You are better than that. Come on. Okay, so remember ammonia and water in toluene. But the guy we care about is silver. Toluene. Silver reduced, silver plus reduced to silver solid. What about Benedict? In Benedict's test, you have copper 2 plus being reduced to copper plus. Okay, so here's the thing. We have the same thing, aldehyde. We don't care about the aldehyde. We know what's going to happen to him. He's going to become a carboxylic acid, right? But what we care about is who else is there? Copper 2 plus. And this copper 2 plus is actually in blue crystalline form. So we call it copper pentahydrate. It's like you have copper and water, right, together. So I'm not going to show you, but it's just we want the ion, the Cu2 plus, which is going to be reduced to Cu plus. So basically here, we don't have to put anything on top of our iron. So wow, Benedict is nicer. And then what happens is you have your carboxylic acid, OH, plus copper plus. Don't forget that. Okay? But this copper plus, they normally write it in oxygen. So it's Cu2O. Okay? Which is, that's obviously a copper plus because O is 2 minus. And we have 2 of the Cus. So that means it was a Cu plus. So that the 2 of them will become 2 plus to cancel the 2 minus. So that's why Cu2O. Okay? That is reddish solid. That's a reddish solid. So here, this is red. This was blue. It comes from blue to red. This was just colorless. Here we have blue goes to red. Reddish solid. That's for Benedict. What do we use? Copper. And that's all you gotta know. And you're done with aldehydes and ketones. Okay? If you want to see a picture, let me show you a picture of Benedict. All right, so here is our Benedict, and it's used for reducing sugars. But in this case, in chem, of course, we'll be using it again, and we'll be using sugars that have an aldehyde. Okay, they need to have an aldehyde trace in them, and what we are actually testing for is the aldehyde, and what we'll end up getting is this brick red, and we said it will be copper 2 plus being reduced to copper plus, but we'll put it in oxygen as a copper 2 oxide, as a copper oxide. Here it is, and that is what you get. This is a reddish solid. Okay, it's a reddish solid or precipitate. Precipitate is just a solid that you see being formed, and that is what you have in Benedict. You are done.